Hello, I'm John Hammond with Indicate Technologies. Welcome and thank you for joining our webinar series on Digitize for Design and Inspection. Indicate Technologies is a leading supplier of equipment and services for additive manufacturing and precision dimensional measurement to the high technology industries of the Western United States. Recently, we have experienced exciting developments in 3D scanning technologies and the related software tools. Each installment of this series will highlight a few key aspects of what is possible with one of these new tool sets. Each 20-minute segment will present a scanner and software demonstrating a workflow for a specific result relating to reverse engineering or inspection. A few items before we get started. Please do ask questions during the webinar. Everyone's audio lines are muted right now, so use the Q&A button to submit your question. We'll respond to them at the end of the session as time allows, and we'll publish frequently asked questions after the webinar. In today's session, we'll present how to recover from a damaged boat propeller using Artec Eva handheld scanner and Geomagic Design X software. This is a reverse engineering workflow that results in a solid model of the propeller so that it can be remanufactured without the damage. My colleague Anton Bosniaga of Artec 3D will do the scanning for us. Okay, Anton, take it away.
Hello, I'm Anton with Artec 3D here at Indicate Technologies, and today we're going to take a look at reverse engineering this broken part with some organic surfaces. So we're going to use the Artec Eva 3D scanner and the Geomagic Design X software. So the Eva, let's first take a look at the scanner. The Eva is a structured light 3D scanner, white light, and it's normally used to scan objects from around the size of a basketball to the size of a car. And we're going to scan this object using the scanner and then move that data into Design X for reverse engineering, and we're going to generate a CAD file. In terms of the part, you see that it has the organic surfaces, the propellers, and that one of the propellers is broken. So we're going to focus on scanning just one of the propellers, and we're going to reverse engineer the rest of the part just from that section. So without further ado, let's take a look at the scanning process. So here is the Artec software. We're running this in Artec Studio. You can see in the viewfinder, we can see the part. Here's the scanning process. We just point the scanner at the part that we want to scan. It takes care of all the alignments, so we don't actually have to align the individual data frames manually. We can just let the computer vision system do this thing. I'm trying to get as much of the propeller as possible. And there we go, that's that. Now we're going to take a look at the processing for this data set real quick. So we see that the software is doing some housekeeping there for us. So we do have a fully processed real-time file. This is the real-time fusion or the real-time meshing result that Artec Studio gives us by default. And you can see it's a pretty complete file. We could just export this file, but it is a file generated in real time. So it's inherently lower quality than